Okay, so yeah, so in this next lesson, what we're going to be doing here is we're actually going to be putting together everything we know about right triangles and solving them. So first thing I want to clear or make clear is what it means by solving. Right. So if you're asked to solve the following triangle, basically what it's asking you to do is to find all missing angles and lengths. Okay, so you need to find all the lengths and all the angles in the triangle. All right, that's not given to you. All right, so before we actually do this example here, I'm just going to list off. There's actually 3 tools we can use. All right, so the first one is what we've been doing so far. Saw, TOA. All right, so sine, cosine, and tangent ratios. The second thing we can use is the fact that all angles in a triangle add to 180 degrees. All right? So if I added up all 3 angles in a triangle, it will always add to 180 degrees. The third thing that we can actually use, the third tool, is the Pythagorean theorem. All right, so again, that was a squared plus b squared equals c squared. Now, the key thing here is the c, so the side that's by itself in the equation is always your hypotenuse. All right, so these 3 tools we're going to use, and with these 3 tools, we should be able to find all the missing lengths and all the missing angles in a right triangle. All right. Now, what you'll also find is that there will come to a point where you can actually use more than one of these to find a certain angle. Right, so you're not just restricted to just using one of these tools. Sometimes you can use 2 or 3 of them to find an angle or a length of the side. Right? Okay, so let's start off here with this triangle. Now, to start off with, what I'm going to do is I'm going to, just like we always do, label our sides. All right, so this across from the 90 degrees, this is my hypotenuse. Now, actually, that's the only side I can label right now. Okay. And so, let's see here, where to start. Okay, so we also have options where we can start. I think what I'm going to start here is I'm going to start with finding angle K. All right, so if this is angle K is what I'm looking for, that would make the 11 centimeters my opposite side and the 7 centimeters my adjacent side. Okay, so what you notice here is that the hypotenuse is blank. So from SOHCAHTOA, the ratio that involves the opposite and adjacent is the third one here, which is tangent. All right, so if I set up my equation here, I'm just going to write tangent of angle K is going to equal my opposite, which is 11.0, or just 11, over my adjacent side, which is 7. Okay. So again, that's using, tangent ratio. So tangent of K is opposite over adjacent 11 over 7. All right, so therefore K is going to equal the tangent inverse of 11 over 7. All right, so so let's punch that into the calculator. See what we get. So 11 over 7, and then second function tangent. All right, so it looks like that angle there is 57.5 degrees. All right, so angle K is 57.5 degrees. All right, so that's the first thing that we found. All right, so what's next? Okay, so let's say I want to find angle N. Now, there's a couple ways I can find angle N, actually. what I can do is I can, again, label these sides. Now notice that if I was to use the trig ratio, this would no longer be my adjacent side, right? This would be my opposite side. Then this would be my adjacent side. So I can use tangent again, right? Tangent n is equal to 7 over 11, and then do the same procedure. Another one I can use here, maybe it's a little bit quicker, is the second tool here, where there are all angles add in a triangle add to 180. Right, so I think I'm going to use that one actually. It's probably going to be a little bit quicker. All right, so n is going to equal 180. So angle n is equal to 180 minus the other two angles. So this was 90 degrees. Angle n was 90 degrees. Minus angle k, which we found out was 57.5 degrees. All right, so I subtract those. So 180 minus 90 minus 57.5. And we get 32.5 degrees. Okay, so as it turns out, angle n there is 32.5. Now there's a third thing that we need to find. So we found all the angles in here. Angle k is 57.5, angle n is 32.5. We also need to find the length of the hypotenuse. All right, so to find this hypotenuse, I could use SOHCAHTOA, or I could use the Pythagorean theorem. Either way, I should be able to get the same answer. So I think what I'm going to do here is actually I'm going to use the Pythagorean theorem. So I'm going to label this hypotenuse as x. It's a different color. All right, so I'm going to call that x. And so therefore, a squared plus b squared equals c squared is my Pythagorean theorem. So my hypotenuse is x, so that's going to be by itself in the equation. I'm just going to write x squared here. A squared plus b squared. So in other words, 7 squared plus 11 squared. All right, so if I solve for x here, I should be able to get the length of x. All right, so 7 squared is 49. 11 squared is 121. All right, so if I add these together, that's 170 equal to x squared. So therefore, so write that again, x squared equals 170. The opposite of squaring is the square root, so I'm going to square root both sides. And as a result, x is going to equal the square root of 170. And as a result, it's 13.0 centimeters. All right, so that would be the length of the hypotenuse. All right, but again, we could have used SOHCAHTOA to find that hypotenuse. Actually, maybe quickly I will. I'll show you, yeah, if I was to use something else, I should get the same value for x here. So let's say instead of using the Pythagorean theorem, I'm going to use, this is my opposite adjacent. All right, so let's say I want to use the fact. Some of this stuff here. Okay, so for angle n, yeah, this is my hypotenuse. This is my opposite side. This is my adjacent side. All right, so let's say we want to find x as my hypotenuse. All right, so I know that angle n here is 32.5 degrees. So let's use adjacent hypotenuse, even though I do know the opposite side length is 7 as well. But anyways, I'm going to use these as to find the length of x. All right, so if I was to set that up here, I would write, so I want the ratio with adjacent hypotenuse, which is the second one here, cosine. I'm just going to write cosine of 32.5 degrees equals adjacent, which is 11, of the hypotenuse, which is x. All right, so if I solve this equation, I should get 13 again. So let's just do that. Let's see what happens. So I'm going to set up a cross multiplication here. So x times cosine of 32.5 degrees equals 1 times 11. And then I'm going to divide both sides by cosine of 32.5 degrees. All right, so these cancel. And let's see what we get. We should get 13, right, if I punch this in here. So 11 divided by cosine of 32.5 equals, yep, here we go, 13.0. All right, so yeah, so there are I just did this last one here just to show that there are usually more than one way to get the answer for an angle or a length. Right. Cool. All right, so let's try another one here. We're going to solve this triangle here. So again, we're going to find the missing sides, missing lengths. So yeah, so I have two angles. Actually, you know what? I think the starting point here is probably the easiest one here is to find angle J. So angle J is, since the angles in a triangle add to 180, if I take 180 minus 90 minus 39, that should give me what angle J is. 180 minus 90 minus 39, we get 51. All right, so angle J turns out to be 51 degrees. Next up, let's find a side now. So yeah, we'll call that one X. Let's find the length of GX. So it doesn't matter which angle I work with. Let's say I am working with, I'm going to use a red pen. I'm going to use this angle here, 39 degrees. If I label my sides using 39 degrees, across from it is my hypotenuse. This is my opposite side. This is my adjacent side. All right, so if I was to use SOHCAHTOA, I want to use the ratio that involves the opposite and adjacent for this angle here. And that is the third one here, which is tangent. All right, so this way they set this up is tangent 39 degrees equals opposite, which is 9, over adjacent, which is x. All right, so I want to solve this equation, and when I solve it, I should get the value for x. So I'm going to set up a cross multiplication. So x times tangent 39 degrees equals 1 times 9, which is 9. Next up, divide both sides by tangent 39 degrees. These cancel. And as a result, we get x equals, all right, so let's punch that in. 9 divided by tangent of 39. We get 11.114. All right, so let's just round it to 11.1. All right. So as a result, this length here turns out to be 11.1 centimeters. Okay, so to find the third side, I actually have a couple options. I can use Pythagorean theorem, right? A squared plus b squared equals c squared. Or I can also use SOHCAHTOA. I think what I'm going to do here is I'm going to use, actually, you know what, it actually really doesn't matter which one, but let's use a ratio again. All right, so this is my hypotenuse. So without being too confusing, I'm going to use the angle 39 because I've already have it labeled. And I'm going to use these two here. All right, so I'm going to call the hypotenuse, actually I'll call it h. All right, so if I set up this here from SOHCAHTOA, I want the ratio involving the opposite and the hypotenuse, which is the first one here. So if I set this up, sine, the angle we're working with is this one here, 39 degrees, equal to opposite, which is 9.09 over the hypotenuse h. Okay. So again, I'm going to set up the cross multiplication. So h times the sine of 39 degrees equals 1 times 9. All right, and to solve for h, to divide both sides by sine 39. These cancel. H is going to equal. All right, so let's punch that in. 9 divided by sine of 39 equals. So we get 14.3 centimeters. Okay, so that is the length of that hypotenuse. All right. So yeah, and I'm pretty sure that if I used Pythagorean theorem, right, 9 squared plus 11.1 squared equals h squared. So for h, I would still get the same. Okay, so yeah, so there's usually more than one way of finding all the missing lengths and sides.